We'll see how it runs. The plan is, this is the last section of chapter 4 that we're doing. We just did 4.1, 4.3, and 4.4. And so I thought it would be a good place to have a quiz. So the plan is tomorrow we'll review, and Wednesday we'll have our quiz over chapter 4, which means your chapter 4 homework will be due on Wednesday. And then we'll start chapter 5, and then we do all of chapter 5. Chapter 5 is polynomial functions. A lot of review of what you did in Algebra 2, but some new stuff. If you took pre-cal last year, it'll be some review of that stuff as well. But chapter 5 is definitely getting into harder stuff, like polynomials, PRZs, synthetic division, find all the zeros, you know, like find all the solutions to like x to the 5th equation. Remember that kind of stuff. It's fun. But today we're just going to do some story problems. So I printed these out for you just because I didn't want to wait for you to write all this stuff down. Maybe. So here we go. It says, we want to be able to maximize an area, and that uses a quadratic model. So it says a farmer has 2,000 yards of fence to enclose a rectangular field. What are the dimensions of the rectangle that encloses the most area? And this is kind of leads into some calculus. We're not going to do calculus, but we could do calculus to do this. But you want to find the maximum amount usually. Like you want to find, if you were making a product, you would want to be able to use the least amount of material to fit the most amount of your product in something. And so maximizing and minimizing stuff is optimization in calculus class. So let's draw a rectangle. Oh, that's a lovely rectangle out here. And what is it telling me if it's telling me that I have 2,000 yards of fence? In terms of math, what is it telling me? Is that the area of the fence? That's the perimeter. That's like if I added up all the way around my rectangular area. Yes? So we could call this whatever you want. If you want to keep x in the problem, we could call one of these sides x. If you just want to call it length and width, we could call it length and width. I don't know. You tell me what you want to do. The book throws the x in there just because they like x for everything. So, x, x. Let's call this x then. We can't call the other side x because we don't know that it's the same. So we have to call this something else. So let's call this w. LW, right? Just humor me for a minute. How would I say the perimeter of this rectangle? What would it be in terms of these sides I just labeled? Not x squared, right? Yeah, like x plus x, or 2x plus 2w equals 2,000. Everybody with me on that? 2x plus 2w equals 2,000. But they want us to find the most area. So what would the area of this rectangle be in terms of the labels that I've given it? How do you x times w? Everybody with me on that? So I've kind of made two equations. And the reason we make two equations is because we have two unknowns right now. And we like x better. So we want to change this in terms of x. Could I solve this equation for w and then plug it in here so that I only have x in this equation up here instead of x and w? So that's why it's okay that we use w, because we're going to get rid of the w. So if I wanted to solve this for w, do you agree that I could subtract 2x and then divide by 2? And would I get that w equals 1,000 minus x, because that divides by 2 so nicely? So I could write an equation, and I'm actually going to change this to a of x. So I'm going to say it's all in terms of x. And I'm going to replace w with 1,000 minus x. Anytime they ask you to find the maximum or the minimum of something like this, that's going to be the setup. Use what they give you, which is usually perimeter. Write an equation. Write the equation of the area, plug in So it's all in one variable, and what we should have is a quadratic. And if I work this out, what I have 1000x minus x squared. Is that a quadratic equation? Yeah, x squared's at the end, but it's a quadratic equation. So here's what's kind of cool. We could graph this whole thing and look for it, but we want the most area. Do you agree that another way of saying the most area would be saying like the maximum area? Is this quadratic equation going to have a maximum? How do you determine if it has a max or a min? Because that's a negative x squared, do we know it's going to open down like this? Yes? We're going to answer that, or did you have a question? So where does that maximum occur? Like at what point on your graph is the maximum going to be? The vertex. Do we have to graph it to get the vertex? No. So the idea is if you can write an equation that's a quadratic and you know the maximums at the vertex, you can find the answer to this without actually having to graph the whole thing. So that's the idea of how we can use quadratic equations to answer these questions. You have options here. If we switch this around, I feel like we're better used to it like this. If this was negative x squared plus 1000x, I think of it like that. We could do the negative b over 2a, or we could do the completing the square. I don't care which way you do it. I did these last night, and I did negative b over 2a every time just because, I don't know, I feel like it's less work. So I did, for the vertex, negative b, which b would be 1000, over 2 times a, which would be negative 1. And what is that? Negative 1000 over negative 2, which is 500. What are the dimensions of the rectangle that encloses the most area? Is x equaling 500, because that's what we just found, the x coordinate. Is that a dimension of that rectangle? If I know that that is 500, can I figure out what w has to be? Can we plug that back in somewhere and solve for w? There's some options. We could plug all the way back into the perimeter if we wanted to, but I think, let's go back up to, well, I don't know, over here maybe? If x is 500 and w is 1000 minus 500, what does w have to be? So to answer this question, what are the dimensions of a rectangle that encloses the most area? The dimensions would have to be 500 yards by 500 yards. So technically it's a square. But a square is a rectangle. But a rectangle is not necessarily a square. Some of those weird things like that. Yes. Yes, sir. Yes, that's what I did right here. Negative b. You could have also completed the square to this. It doesn't ask you on this, but it could ask you to actually find what that maximum area is. And you could just multiply that, 500 times 500, to get that. How do you feel about that? Maximizing or minimizing. They could ask you to find the minimum of something, of a problem. Yes, go. No, because, let's think about this. I want an add page, and I want a new page. So our answer ended up being 500 by 500, which would actually be, right, 250,000 square yards, yes? If it's 2,000 perimeter, what else could it be? Could it be, could one side end up being, I don't know, let's think about this. side was 250, that would make this 250, which is 500. So what would be left? 1500 divided by 2 would be 750, and 750, man, I don't want to do this math. What's 750 times 250? Not 250,000. 187,500. Because depending on how you make it, although the area, like the perimeter is the same, but it is going to change the area. And so that's where making a square, maybe you'll notice this, that usually if you're trying to maximize area, making a square will always get you the biggest area. We could go really like long and thin, like if this was 1 yard, that's really small. This was 1 yard by 1 yard. That would leave 1,998, which is, oh yeah, 999. That's only an area of 999. Like, that's really small. That's not good, right? So the closer that they get to being the same length, the bigger the area gets. This little geometry stuff to get it there. So you could guess and check this. That's not very much fun. That's why we can do this little formula. Yeah, how about that? We went to the new today. They don't have enough room. Okay, what about this one? This is really why I printed your notes out, because this one's kind of crazy to write all this down. The other part, there's other things in this lesson, but the two types of problems that show up on the unit test are the maximizing or minimizing something, and talking about projectile motion. And projectile motion is something that we talk about even all the way back in Algebra 1, and the higher math you get, the more we talk about this. In calculus, we talk about it all the time. But it says a projectile is fired from a cliff 200 feet above the water at an inclination of 45 degrees to the horizontal, with a muzzle velocity, which I kind of laughed. I was doing this last night, and I asked my husband, what's muzzle velocity? He's like, it's the velocity when it came out of, like, the muzzle. And I was like, in calculus, we always call that the initial velocity, like where it starts. But this was a new one for me. The muzzle velocity. 50 feet per second. The height h of the projectile above the water is modeled by this ugly equation. They left this as 50 squared because they want you to see that that's coming from the initial velocity. You don't have to leave it as 50 squared when you work it out. The negative 32 comes from, like, the gravity on Earth, like something like that. And notice this 200, not a coincidence that that's where it started from, 200 feet on a cliff. We'd like to talk about this when we talk about quadratics, because if you think about firing something or throwing something or shooting off a rocket, it's going to make the shape of a parabola. No matter how straight it goes to begin with, eventually it's going to reach that maximum, and it's going to turn, and it's going to fall to the earth. Sometimes it's going to be a really, really big parabola. Sometimes it might pretty much go straight up and turn and fall straight back down, but that's still going to be a little turning point there. So notice that this is still a quadratic, where x is the horizontal distance of the projectile from the face of the cliff. So x is like how far out it's traveling. And look at part A. It says, at what horizontal distance from the face of the cliff is the height of the projectile a maximum? That's a whole lot of words there. But here's the big thing. If we know it's a quadratic and it's negative, we know it's going to look like this in some degree. Yes? So what are we going to do to find that maximum? Find the vertex. I don't know about you, but I don't want to complete the square on this one, right? This is definitely where the negative b over 2a is going to come in handy. I tell you that I got out my graphing calculator last night, because that's all I had in my bag, and the batteries were dead. So then I had to use my calculator on my phone, which, let me tell you, is not as handy as these calculators, because you have to do everything. It's like the opposite way. Like, instead of hitting like square root and then the number, you have to hit the number and then square root, and this was not very fun to do over and over again. Because it's an iPhone. Your calculator on your phone would be the same. Do you have a calculator on your phone? It's not as cool either. Well, I have all the buttons, but it's I don't know. I was typing in fractions and I was just annoyed that I didn't have my fancy calculator. But here's the idea. We're doing the vertex. And the vertex is negative b over 2a, and then f of negative b over 2a would give you the y value. Do you know which one of them I need? If I want the horizontal distance when it's a maximum, do I want the x coordinate of this or the y coordinate of this, or do you have no clue what I'm talking about? It says right here that x is the horizontal distance. So if they want the horizontal distance, I just want the x value. The weird part is a is a really ugly number up there, right? But you have a calculator, you can use the calculator. So I just said b was negative 1 over 2 times a, which a happens to be negative 32 over 50 squared. I don't know. I did the bottom first, and then I wrote it out, and then did 1 over that. Anyone have a question on where I'm getting those values from? No, because a is just a number in front of x squared, right? Like, you could really pull that x squared out next to it. I used the fraction button for the bottom instead of a division sign, and it kept it as a fraction. On my calculator last night, I did not have a fraction button, so I just did it as a decimal. I don't care either way. But if you do this, on the bottom you get negative 512 over 625. Which is just going to flip that around, right? That's just going to be 625 over 512. Did anybody get that? I don't know if that's the right answer. 1 point. I don't feel like I think I did better on my work I did last night. 625 over 16. Did you get that? Yeah. Sorry. Okay. Failure on my part. 16, negative 16 over 625. Did you get that? That was just on the bottom? Or that was all together? So then if you flip it over, it just gives you 625 over 16. Or if you're a decimal lover, 39.0625 is what you end up with. So check and see if you can get some version of that. Because there's one on your homework that's a weird fraction like this. I'm okay if you left it at 625 over 16. Like, that's a fine answer. The book, and the answer they give in the book is they give this, and then they put approximately 39 feet. So they just drop the decimal, which I'm not a big fan of. And that's telling you that when the projectile reaches its highest point, it's 39 feet away from the cliff, from where it was fired. Questions about that? The big thing about this is all stuff we've done. It's just you have to read it and know what you're talking, like whether you're talking about the x value of the vertex or the y value of the vertex. So look at the next one here. I think that you have another page here, right? Part B says find the maximum height of the projectile. So if this is the x value, about 39 feet, how would I find how high that projectile actually went? And find the other part of the vertex. So this is the x part of the vertex. To find the height, it tells you the height h is the y value here. All you have to do is plug that in, and I just plugged in the decimal again because I didn't have a fraction button last night. So I just plugged in h of 39.0625. I'm going to cut that here because I totally don't have enough room up there. So that's going to be negative 32 times 39.0625 squared over 50 squared plus 39.0625 plus 200. Again, you're welcome to do this all in one step, or just do the first part and then add each second part. Like I did the first part on my calculator and hit enter, and then I added the 39 and the 200. And remember, like, you should be able to tell me if the answer makes sense. We're starting at 200 feet above the water, and we're up in the air. Like, I feel like our answer should be above 200 feet. I'll tell you what I got, and then you tell me if you're getting the same thing. I got 219.5 because this is a negative number and then this is a positive number, so they kind of cancel each other out a little bit. Negative 32 times 39.0625 squared divided by 50 squared. It should be like negative 19.53 something. No, this whole thing right here. That's my whole answer. I was just trying to give you an idea if you didn't get that. That this should be like negative 19 something. The first time I did this, I forgot to square that, so my answer wasn't right. But again, knowing that it's asking for the vertex, that's what you're looking for here. Now part C and part D are asking you to solve an equation, but you have to figure out what it's talking about. So look at part C. It says, at what horizontal distance from the face of the cliff will the projectile strike the water? So it's asking us horizontal distance. Does horizontal distance represent the x or the y in this problem? The x. They're asking us to find x when the projectile hits the water, which means what is the height of the projectile when it hits the water? How high will the projectile be from the water when it hits the water? 0, yes? Does that make sense? So instead of asking you, hey, how long will it be before it hits 0, they ask you how long will it be before it hits the water. So you have to know this is saying h equals 0. So they're asking you to solve this equation when 0 equals negative 32x squared over 50 squared plus x plus 200. Who's excited about solving that problem? How do we solve quadratic equations? We could factor, right? Can I factor this? No. What else can we do to solve equations? Quadratic formula or complete the square? I don't know about you, but I don't want to complete the square with that ugly mess in the front. So this is where I would do quadratic formula, and I did quadratic formula. This is Parker's picture that he drew when I did my homework on it last night, because I couldn't figure it out. And it looks kind of ugly, but it's a lot of calculator stuff. And I did it with a horrible calculator, so you should be able to do it. So I'm just going to put underneath this quadratic formula. Maybe I should have given you more room on your paper to do this. But quadratic formula is x equals negative b, so that would just be negative 1, plus or minus the square root of b squared, which is 1. You could change this to a decimal if you want, right? Like you could just use that as a decimal, but I just kept typing it in my calculator. Minus 4 times a, which is negative 32 over 50 squared, times c, which is 200, all over 2 times a. Don't forget that 50 is squared on the bottom. And honestly, I didn't show a lot of work from here because I used my calculator, even a terrible calculator. So I started with this underneath the radical. It better be a positive number because we can't have an imaginary time. And it should be positive because a negative times a negative. But I think on my calculators, if you just type what's under that radical and straight in, 1 minus 4 times negative 32 divided by 50 squared times 200, you should get, under the radical, 11.24. And I just typed that straight in, like exactly as it is. And I did the same thing with the bottom. 2 times negative 32 divided by 50 squared, and I got negative 0.0256. The bad thing about story problems is most story problems don't work out nicely, so you have to deal with decimals, but the good news is you have a calculator. What's the bottom number? I think that should be, if you do this, it should be 0.0256. And now you got to work it out. There really is two answers here, but think about, we're talking about how long it takes, which means if you get a negative number, can you have a negative time? So if we get a negative number when we work this out, like it doesn't make sense for the problem. And so the first one that I did the positive root. I did -1 plus the square root of 11.24 divided by that lovely number in the bottom. And I got x equals negative 91.9 feet. I guess we're about feet here. That doesn't make sense to the problem. So if you know it's going to be negative, you don't have to do that one. But if you do the minus, it's going to work out. -1 minus the square root of 11.24 divided by negative 0.0256. You get like 170.02 feet. That is a reasonable answer. That projectile is out 170 feet from the cliff before it hits the ground. How about that? Excited? Definitely nice to have calculator. What about part D? Part D says when the height of the projectile is 100 feet above the water, now how far is it from the cliff? Does that ask you to solve for x again? When the height is 100 feet from the water, how far is it from the cliff? Where am I going to put that 100 at? Which means instead of having 0 here, would I just have 100 there? Because now the height is 100. Which means to solve that, you'd have to subtract 100 over here. So it's another quadratic problem. So you would have 100 equals negative 32x squared over 50 squared plus x plus 200. And you would subtract 100 over, which means you're going to have to do quadratic formula again. So now C is 100 instead of 200. And again, you get one answer that's negative and one answer that's positive. I'm going to not even work this all out. I'm just going to tell you that you're going to do the quadratic formula again. And you should end up with like 135.7. I can tell you for 100%, there's a question on the unit test talking about projectile motion. It asks you about the maximum height. It asks you how long it takes to get there. And it asks you questions like this where you have to plug in and you have to solve it. So, of the stuff that we've done in this chapter so far, this section is what's on your unit test, is these applications of it, being able to find this. There's not really a question that just says, hey, is this a max or a min? They're giving you some story problems. Okay, so that's how we have our unit test. We're going to probably have forgotten all about this, but hopefully we'll be able to use our quiz to remind ourselves and see how we do on this. So try these. If you're not at least trying to set them up yourself, you're going to really struggle. You're only doing 7, 8, and 12. 7 and 8 are the maximizing area, which aren't so bad, and 12 is the one like we just did. I'll tell you on 12, there's parts A through E, but you're not going to do parts D and E, because D and E are graphing calculator stuff, and we're not using a graphing calculator because we're not allowed to use one in this class at Ivy Tech. Okay? follow the rules, Sawyer. So try those. Try 12. I'm not going to do every part of 12, but if you get stuck on that, I might help you set it up tomorrow. But just because you don't want to do quadratic formula, don't think I'll do that whole problem for you tomorrow, okay? And I thought we'd get to these notes quicker.